For every mirror, the angle of incidence is equal to the angle of reflection. However, if I have a curved mirror surface, measuring that angle is a little bit more difficult to do. We would have to draw a tangent line to the circle of the concave mirror, then draw the perpendicular to that to measure the angle. So when we go to draw our ray diagrams, we're going to do it a little bit differently. When I have a curved mirror, there is what's called a principal axis. And if I have multiple rays going parallel to the principal axis, they will all converge at a single point. So for this one, all of these rays are parallel to the principal axis, and all of the reflected rays are coming back and meeting at this point right here. This point is called my focus. And this line that contains the focus is the principal axis. Now, when I'm going to draw my ray diagram for an object, what I need to remember is if any line is coming in parallel to the principal axis, it goes out through the focus. However, the angle of incidence equals the angle of reflection. It doesn't matter which of these is the incident ray and which one is the reflected ray. If I take another ray and make it go in through the focus, it will come out parallel. So if I turn this off and show this ray coming in through the focus, it reflects out parallel to the principal axis. So without actually having to make those rays, I can draw any line coming in parallel to the principal axis. The reflected ray will go through the focus. Any one coming in through the focus will go out parallel to the principal axis. Then the third rule is if it goes in through the center, it's also going to go out through the center. And we'll look at what that means in our ray diagrams. So unlike a plane mirror, I can't just draw my image very quickly. I need to actually look at the incident and reflected rays to find out where my image is going to be. But we're going to use those three main rules in order to draw our image. So here I have object, which is this arrow here, and I have an eye drawn up here because we're going to look at how we actually see the object or the image of the object as well. So the first thing I'm going to do is I know that if I go in parallel to the principal axis, the ray that reflects off of that, it's going to bounce out through the focus. So I'm going to draw all of my incident rays in red and all of my reflected rays in orange so I can keep track of what I'm actually looking at a little bit more easily. So in parallel, out through the focus. Now I'm going to draw a line that goes in through the focus. So if that ray goes in through the focus, it's going to bounce out parallel to the principal axis. Now where those two rays converge, every other ray will converge. But just to show that, we're also going to do our third one, which is if it goes in through the center of the mirror, it's going to go out through the center of the mirror. Now, where all three of the reflected rays meet, so I'm looking at where all three of the orange rays meet, that is where the head of my image is going to be, because the light rays bouncing out of the head of the image all go through that point. So now I'm going to draw the image right here. So when I go to describe that image, the image is smaller than what I started with. So my object is that big, my image is smaller. So the size is smaller. The attitude would be either upright or inverted. In this case, it's opposite what the object was. This one is pointing down, so it's inverted. And type. The type means, is it real or virtual? A real image is one in which the light rays are actually passing through that area. These light rays are actually passing through that point, so the type is a real image. Now, in order to determine how I can see, or if I can see this object based on where my eye is, well, see the image based on where the eye is, I'm going to need to draw some more rays. Well, in order for my eye to see the image, I need to have a light ray that bounces from the object to the mirror through the image to my eye. So I'm going to draw a line from the eye through the image to the mirror. So this is the path that my eye would take. Well, that light ray that's bouncing to my eye from the tip of the image has to have originated at the tip of the object. So I have a light ray bouncing from the tip of the object to the mirror and to my eye. And I'm going to do that for both the head and the tail. So eye through the image to the mirror, and I'm going to draw all of the lines that are going from my eye to the mirror in green. And then that one came from, well, that's how I'm seeing the tail of the image, so that one came from the tail of the object. So I have one light ray in blue bouncing from the head to the mirror and bouncing to my eye, and one going from the tail to the mirror and bouncing back to my eye. So I can see this object because, or I can see the image of this object because I have light rays from the top and bottom that are bouncing off of the mirror and making it to my eye. Now this one happened to have the object farther away from the mirror than the center of the mirror is. The process is going to be the same regardless, but sometimes our lines are going to be drawn dotted. And we're going to draw dotted lines if we're trying to show that we're lining something up with a specific point, but the light isn't actually traveling there. So for example, when I go to do this one that has the object closer to the mirror than the focus is, I'm going to draw a line that goes in parallel and out through the focus. And the light actually is traveling along that whole distance, in here, out through the focus. But when I go to do the one that's in through the focus, well, that light's actually starting at the head. But I want to show that it's lined up with my F dot. So I'm going to draw a dashed line until I get to the head of the object. So this shows that this ray, which is actually bouncing off the head of the object, is lined up with the focus, even though the light isn't actually coming through that point. So I have in through the focus, out parallel. And then we're going to do the same thing in through the center, but I'm already closer to the mirror. So the light's not actually going to be back here, so I'm going to draw it dotted until I get to the head of the object to show I'm lining this one up with the center, and then it would come out through the center as well. Now in this case, my lines don't actually meet. They're getting farther apart with the reflected rays. Well, it would appear that they were meeting behind the mirror. So what I'm going to do now is extend these reflected rays back behind the mirror until I can see where they meet. So this one was the out through the center, and I'm going to do those in dotted lines because the light doesn't actually go behind the mirror. So all of these lines, and again I should have dotted this other one that's behind the mirror as well because the light does not actually travel behind the mirror, appear to be meeting over here. So this is where my image is going to be. So I'm going to draw in the image. Now for the size, this one is enlarged or magnified. It's bigger than my object was. Its attitude, it's still upright. And the type, well, my light rays don't actually go through that point. They just all appear like they're coming from that point. So the type is going to be a virtual image. Then for how I see it, again, we're going to draw a line from the eye to the mirror. And we're going to do that in green. So eye to the mirror, but it's showing me how I'm actually seeing the image. So I'm going to line up my eye with the head of the image, and I'm going to draw in green a line that reaches the mirror, and then I'm going to dot it behind here to show that I'm lining this up with the head of my image. And then from the mirror back to the object in blue. So I have a line going from the object to the mirror, bouncing back to my eye, and I'm going to do that for the tail as well. So eye to the image, through the mirror, dotting it if it's behind the mirror, and then from the mirror to what I'm seeing the image of, which in this case is the tail. So there's also a ray going from the tail to the mirror that bounces back and does reach my eye. So you're always going in parallel, out through the focus. In through the focus, out parallel, and in through the center, out through the center, regardless of where my object is relative to the center and the focus. If those reflected rays meet, that's where your image is going to be. If they don't actually meet, then you're going to trace those reflected rays back behind the mirror to where they appear to be coming from. And then you're drawing a line from your eye to the image, and then the mirror to the object, showing the light ray that's going from the object to the mirror, and the reflected ray bouncing back is where you're seeming to see the image from.